Fourth type of function, rational functions. So we know what a rational number is. A number, suppose n is the number, which can be denoted by p by q, where q is not equal to 0. This is a rational number. Now what is a rational function? It follows the same concept. Rational function is a function which can be denoted as the quotient of two functions. So if f of x divided by g of x would mean a rational function where g of x would not be equal to 0. This is a rational function. I'll read out the definition. A function that can be expressed as the quotient of two polynomials where the denominator polynomial is not 0. Okay. And examples of these are f of x equal to 1 by x, where x cannot be 0. If this is 0, the denominator will be 0, which is not possible. The graph of such a function would look like this. If f of x is 1 by x, the graph would look like this, where this is a line which never touches x nor y axis, but it is really close to it. So these lines do not touch the x or y axis, but they travel very close to it. X cannot be 0 in this case. Another example would be f of x would be equal to 1 by x square. Here the function would look something like this. Where nothing touches the x or y axis. Though it may look like it, it never touches the x or nor y axis. Fifth type of function is the modulus function. Now this is a very important function. Suppose this is also called an absolute value function. I'll tell you why. The definition of this is f of x equal to mod x. So mod is another type of operator which would mean x if x is greater than or equal to 0 and negative x if x is less than 0. Okay, I'll explain what it is. These type of functions where there's two possible outcomes based on the condition is called a piecewise function. So I'll tell you, if f of x is mod x, by definition we have some examples. If f of negative 1 is a number less than 0, so that would mean it would arrive here. So we have to do negative of negative 1 because it's negative x. X here is negative 1. So f of x is mod x, where if negative 1 is less than 0, which it is, then we have to apply this negative of negative 1, which would be positive 1. Same wise, if we put positive 1, we arrive at the conclusion 1 is greater than 0, hence we just write f of x equal to x, so f of 1 equal to 1. So the basic principle is that it will always return a positive number, negative of negative 2, which is equal to positive 2. So this function is mainly used to return the absolute value of the input it is given, and it can be represented geometrically. It has a geometric meaning, which is the magnitude or distance of a number from origin regardless of its sign. So it represents the distance from origin. Like for example, if I draw the graph of this function, if this is x and y axis, it would look something like this. Okay, or something like this. This would be f of x equal to mod x, and this would be f of x, which is equal to x plus 2 mod. So I'll tell you what this means. If we have a number 2 here, f of mod x would represent this distance from the origin, which is 2. Alright. So modulus geometrically means the magnitude or distance of a number from 0 regardless of its sign. So even if we take negative 2, the distance from 0 would always be 2 units. And here the domain can be any real number. We can put any real number into these functions, but the range would always be r plus. R plus means only positive real numbers, because the range, the output would always be positive, so the range is also positive. Now there can be equations to solve based on modulus function, like for example, if they give mod 2x minus 3 equal to 5 and asked to solve x, we have to solve 2x minus 3 equal to 5 as first equation, and we have to find 2x minus 3 equal to minus 5. So the mod operator basically works as a plus or minus symbol. 2x minus 3 equal to 5. You can read this as this when you're solving a problem and solve two different equations. So if we solve this, x would equal to 4 in this case, and x would equal to negative 1 in this case. So we get two answers of 4, which is totally normal for a modulus related question.